Alright. When you read a problem and you have two or more chemicals in the problem, you have to write a balanced equation. Now, the two chemicals that are in the problem are not usually water. But if there is water in it, you're looking for other words like react, burn, combust, produce. Those words that indicate you have a chemical reaction happening. If it has dissolved in it, you're making a solution. And you are not then having a reaction. Dissolving is a physical process where react, burn, produce, combust are chemical processes. I think you two need to separate. Y'all can't handle listening and writing and taking notes. Okay? So, the first thing you do is write a balanced chemical equation when you read. I am reviewing you on stoichiometry. That's what we're doing right now. So we write a balanced chemical equation. So let's read number 1 on page 1. It's actually not number 1. It doesn't have a number at all. Calculate the number of moles you would have if you had 10.5 milliliters of a... That's the wrong one. It's not one anyway. Let's do number 4. Number 4, the quantity of the products can be calculated once the moles of the reactant have been determined. Calculate the number of moles of PbI2 formed when 500 milliliters of certain molarity Ki reacts with excess lead nitrate. How many chemicals are in that equation, in that problem? 3? Okay, 3, you're right. So we have to read the problem and figure out what reacts together. What does react together? Ki reacts with PbNO3 2. I know one of the products because it tells me something else here. But whether it tells me or not, what type of reaction is this? Double displacement. What stays at home? Positive part. So K plus Pb. What moves? NO3. So Ki plus Pb. My bad. K NO3. And then the I moves. And because Pb is a plus 2, I must have a 2 by to balance because I is a minus 1. Now I need to balance. My atoms. So K is balanced, I is not. I have to put a 2 here and a 2 here to balance my equation. So write a balanced equation. Now I need to read the question and determine what I'm looking for and what I know. Now don't go back to that 3 given business or that 4 given business. You actually have to read these problems to figure them out. All that stuff's out the window. Okay? Pretty much. We have to find out, well, what do I need to know? What am I looking for? I'm looking for X moles of what? PbI2 equal. Now, I have 2 things that I know. Looking at those, I have 500 milliliters and 0.55 moles per liter. Am I looking for a fraction? That part doesn't go out the window. No. So which one of those should I start with? The 500 milliliters. So 500 milliliters of solution. I don't have to write down that it's Ki because that's not really Ki. It is Ki and water together. It's a solution. Is equal to, or do I need to be able to change? What's the first step of, now I've got my equal to, what's the first step of the 3-step process? Change what I know to moles. I know 500 milliliters. What in the problem will help me change it to moles? I've got to change it to liters? Not necessarily. The 0.55 0.55 moles of Ki. Oh, my writing is terrible right there. Let's do it again. 0.50 moles Ki, 1,000 milliliters. Because I know that 1 liter is equal to 1,000 milliliters. Rather than putting in an extra step, I can change it right there. Because if it's equal, it's equal. Right? Now, if you want to put the extra step in, there's nothing wrong with that. It's okay to do that, but you don't you can do it by knowing that things that are equal are equal. All right? When I get through with this calculation, what do I have? Moles. So have I changed it to moles? Yes. So we have a different way, a new way to change our known to moles. We use the molarity to do that. Okay? And the good thing about it is you don't have to add stuff up. What's my next step in stoichiometry? Mole-to-mole ratio. Where do my numbers come from?
The balanced equation.
And the coefficient in the balanced equation. So I have Ki, 2 moles Ki, and I'm looking for PBI. It's 1 mole PBI2. Can I stop? Yeah. What am I looking for? Moles of PBI. I can stop. But if I don't have moles of PBI over there, I have to continue. And the last step of the 3-step process is to change the moles that you have to the unit you need. I'm at moles. I don't have to do anything else. I just calculate. Okay? All right, let's do number 2 on page 7. Well, do number 2 on page 2. Number 2 on page 2. Can I erase this? Okay. Oops. Do I have more than 2 chemicals? If so much BaNO3 reacts with excess sodium sulfate, I have 2 chemicals given right there. So that tells me I have to have a balanced equation. All right, so my balanced equation is BaNO3 2 plus it reacts with NaSO4, that's Na2SO4, and that yields, what type of reaction is it? So I leave what at home? The positive, and swap. So BaSO4 plus NaNO3, and I have to have a 2 there to balance it. Now, what am I looking for? I'm looking for molarity. Now, right here on the B step, it says note. If you are looking for molarity, stop at this point and do this second step. X molarity equals the answer to the B step over the volume that's given. Now the volume, you are probably going to be given 2 volumes in these problems. So you're going to have 2 volumes in most of these problems. And look at this particular one. Do I have 2 volumes?
Yes.
Yes. So let's read the question, or let's read through. If 25 milliliters of this stuff reacts with excess to produce 55, that's my end product, isn't it? So that would be something I'm probably going to put in the second step, because that's my end product. So I'm going to write my second step right down here. My second step is X moles over liters equal. I'm going to have to get an answer to put on top, aren't I? But I just found out that 55 milliliters is the product is produced. So what's going to be the volume of my final solution? 55. That's the volume of the final solution. You have to read these problems. I can't give you little hints on how to work every one of them. They have to be read and they have to be analyzed and evaluated. That is a DOK 3 and 4. You've heard DOK before in some other classes. That means that you have to use your brain. You can't just be given some little halfway hint on how to do it. It's not the dog is black, and then turn around and question says the dog is blank, or multiple choice, or whatever. All right, so what am I looking for? What do I have to know to get molarity? I have to get moles. So am I looking for moles? X moles of what? X moles of NaNO3. What am I trying to get the molarity of? What am I trying to get the molarity of? NaNO3. The 55 milliliters is the solution of what? NaNO3. The 25 milliliters goes with the BaNO3. That's not the same chemical. The way to get from this chemical to this chemical is to do something to use mole-to-mole ratio. It's the bridge that carries us. Mole-to-mole ratio is the bridge that carries us from one chemical to another chemical. Okay? So X moles of NaO3. Looking at my other givens, I've already accounted for 55, haven't I? Does anybody not understand about the 55, how I accounted for it? It's produced. What's going to be left in the end?
I got that part, but why is it on there like moles over liters?
What's the question in the problem? What is the molarity of the final solution, right? So what do you have to know to get molarity? Moles over liters. So I've got to determine which one of those liters is going to be my final solution. Milliliters. Okay? So once I determine that, I put it down here so that I don't look at that anymore until I get through the first step. I just did that so we eliminate that from our thought process and put it down here. Don't think about it again until I get ready for the second step. Two-step process. Okay? So now I'm going to take my X moles of NaNO3, and that's going to equal, is the moles a fraction? So I'm going to say it equals to 25.5 milliliters. All right, I need, what's the first step of my three-step process? Change it to moles. What can I use to change milliliters to moles? The molarity. The molarity. So 1,000 milliliters, and on the top I'm going to put, wherever the molarity is, get that out of my face. So 3.0 moles of BaNO3 2. All right. What do I have when I get through that? Moles of BaNO3. Can I stop? No. What's my next step? Mole-to-mole ratio. Looking at the balanced equation. 1 mole BaNO3 2. And on the top, I'm going to put 2 moles NaNO3. What's that answer going to give me? What? What is the molarity, Adam?
Oh, okay, over thing.
Yeah, yeah. This is the molarity. Yeah. So I'm using. Get my thing. I'm using molarity there, and of course here is the mole-to-mole ratio. These problems, you're going to use molarity in them somewhere. All right, at this point, I'm left with what unit? Moles of NaNO3. Is that what I want? Yeah, so what was that answer?
1.53.
1.53 moles. Okay. 0.153 moles of Na. I'll get it in a minute. NaNO3. No, not really. You finish it up with your step finger. Okay. Don't round off when you've got a two-step problem. Don't round off till you get to 5. Now, some of you may recognize that you could do this in one big long step. If you do, you can do that. I'm not going to teach you how to do it, but if you can do it, you can do it. All right, so what do I need on top to get molarity? Moles. So 0.15, let me get the right color so that Courtney can see. 3 moles of BaNO3. BaNA. I want to keep going back to BA. NaNO3. Can I stop?
No.
No, I don't have liters on the bottom. So the last step, of course, is 1,000 milliliters, 1 liter. Now, some of you have used milliliters and liters enough and understand them enough that you know that to change milliliters to liters, move the decimal to the left 3 places. If you know that and you can do that in your head, you're welcome to do that. Same step. Not going to teach you how to do it, but if you know how to do it, you can. And you know how to do it, you can probably do it. All right, so when I finish, I've got my answer, and my answer is in molarity.
You have to worry about.
Yes. At the end, Danielle, at the end. All right. Now I'm going to review. I'll come back and answer questions if we need to, but I'm going to go on and I'm going to review limiting reagent problems. Here's a review of limiting reagent. Limiting reagent problems. Are we listening or are we just talking?
Wait, I have a question.
All right.
Okay, do you have to look at both problems?
Like the last.
What for your chemistry? You have to look at just your last.
You have to look at both of your steps, yes. Every number you use to calculate, so there'll be 2 separate figures in that answer. Okay? Limiting reagent problems. You're going to have 1 or 2 of these. How do you recognize that you have a limiting reagent problem? You have 2 sets of given about 2 different chemicals. Now, in these problems, you may be given so many grams of one and so many milliliters of a molarity of another. You got me? But you're given 2 sets of given for 2 different chemicals, and they're both reactive. They're both reactive. If they're both reactive, that means I have to go through this process. Pick a product, any product. Do 2 stoichiometries. Pick the smallest answer. This is the limiting chemical, and the other is the excess. Remember this? Okay. If they ask you how much excess is left, do a 3rd stoichiometry, setting the excess chemical equal to the limiting chemical. the excess to the limiting. Then subtract the given amount from the answer in the third stoichiometry. Now this lecture will be online. All right? So I'm going to stop.